Okay. The first problem in this project is just to find morning start time. Um, we don't have an exact location where that's going to be because our only position is at 0400. So we're going to actually have to look up an approximate point where we can place down a DR position. So how you usually want to start that is you just want to pick what civil twilight will be approximately at your closest latitude. There's no way to get this perfect. It's all pretty generalized. But we are on November 4th, so we're going to come all the way towards the back of the book. Six. Okay, here's the third, fourth, and the fifth. And you can see if we come over to the sunrise section of the book, back here, we're in approximately 18 degrees north. So if we look at 20 degrees north, we've got a civil sunrise, still blurry. Or we got civil twilight at 5:40-ish. It appears we're going from 5:14 to 6:03. So 5:40 is where we're going to set our DR position, or where the time will approximately be in and around start. So before we start writing on anything, we actually got to set that DR and find its position. Okay. So we're going from 0400 to 540. That's, an hour 40 minutes. So 60 plus 40, we get 100 total minutes. Remember, distance equals speed times time. Distance times 60 is equal to speed times time. So we take our minutes, multiply it by our speed of 15, divide that by 60, we get 25. So that's the distance we're going to travel between 0400 and 0540. So we measure out 25 miles. Right there. Mark it, and then you can find the pencil. There it is. That right there is 0540. Now that's only helpful once we actually apply it by measuring out what that is. So we need its latitude and longitude. Latitude is nice and quick. We can just line it up like this, pass that straight across to the latitude scale. You can see we get a value of, looks like 1 minute below the line of latitude, the parallel. So that would get us, 17 degrees, 59 minutes. So we'll write here, 40 DR, 17 degrees, 59 minutes north. Now we need a longitude. So we're going to see how far we are away from this meridian, which is 162 degrees east. Get that. Bring that down to our scale. And we've got, looks like 12 minutes. So 162 degrees, 12 minutes east. So there we go. 162 degrees, 12 minutes east. So now we can actually find sunrise and start time for this general location. So we come back to actually before we do that, we should set up our table that we're going to be working off of. Remember, we're going to have to pick, we're going to place in the center our latitude of 17 degrees, 59 minutes north, and we're going to compare that to whatever the two values are above and below it, which we don't know exactly what those are yet. It's usually on the 10, but sometimes it's on the 5. And then we're going to write out nautical, civil, sunrise. So we come to the book. You can see our options are 10 degrees and 20 degrees, so we'll pick those as the bracketing values, what I've heard it called. So we got 20 degrees north, and we got 10 degrees north. Now we actually need our values for 10 degrees. So at 10 degrees north, nautical twilight happens at 0504. Civil twilight happens at 0529. And then sunrise is 0551. Then at 20 degrees, we got 514. 0540 and 0603. Okay. There we go. Now we can actually perform the job of interpolation between these two sets of times. So remember, we got to set up our fraction here. So we've got 20 total degrees of difference between the two latitudes compared to 7 degrees 59 minutes to our chosen latitude. And that is going to be equal to x over, you can see this total span, which is 10 minutes, and x is that smaller span. And that'll also be equal here, see 0540 to 0529, that's 11 minutes. And then in this case, 12 minutes. Okay. So, firstly, we just do 59 divided by 60 plus 7 to convert that to degrees. Divide that by 20. Oh, I'm sorry. That's 10, actually. Well, the total span from 10 degrees to 20 degrees is 10 degrees, not 20. There we go. Okay. Now this is our fraction. We're going to compare that to each of these. So multiplied by 10 gets us 7.98 here, which we can round that to 8. And if we bring it back, multiplied by 11, we got 8.7 or 8.8, which we'll probably round that to 9. And then if we take it again, this time we multiply it by 12, we get 9.57, 9.6. We'll either keep it at 9 or 10. And we're going up from 504 to 14. So we're going to add 8 minutes here, and we'll get 0512. We're going to add 9 minutes here, and we're going to get 0538. We're going to add, yeah, we'll do 10 minutes. 10 minutes to here, and we'll go 0601. Okay. So these are our times of, civil, nautical, and sunrise, but only correct, accurate to our latitude. Now we have to adjust it to our longitude. So remember, we're going to find what our central meridian is and compare it to our actual longitude. So we'll write out zone description, central meridian, then dr longitude to get the difference, and we'll convert that difference to time. So our zone, we are in 162 degrees 12 minutes east. So we'll do 12 divided by 60 plus 162. If we divide that by 15, we get 10.8, which rounds to 11. So we're in ZD 11. We're in the east, so this is going to be minus 11. So now we know that our central meridian is whatever meridian defines minus 11 hours zone time. So if we do 11 times 15, we get 165. So our central meridian is 165 degrees east. And we'll just write again 162 degrees, 12 minutes east. So now we'll find the difference between the two. See, 164 degrees, 60 minutes. This is another way of writing that. And 162 degrees, 12 minutes. Take the difference, and we get 48 minutes here, and then 2 degrees. So we're 2 degrees, 48 minutes away from our central meridian. Now we're at 162, it's at 165, so it's further east than we are. So we're sunrise is going to occur later for us than it does at the central meridian. So this 2 degrees 48 minutes is going to be applied as adding time, not subtracting it. So if we convert that to full degrees, 48 divided by 60 is 0.8. The difference is equal to 2.8 degrees. If we take 2.8 and perform arc to time, either using that table or just multiply it by 4, we get 2.8 times 4, 11.2 minutes. Which 11.2 might as well be 11 minutes. So we're going to now add 11 minutes to each of these times. So if I write that out again, let's see. We'll add 11 minutes to 5:12. That gets 05:22 or 23. 11 minutes to 5:38 gets 05:49, and to 6:01 gets us 06:12. Okay, so we've got times. Nautical twilight is 5:23, civil twilight is 5:49, so pretty close to what we guessed it was going to be based off of our DR position, but not exactly. And then sunrise is 6:12. Remember though, we're only being asked to find start time, so none of this actually matters yet. We have to now calculate start time based off of these values. So if we go halfway between 49 and 23, let's see, 49 minus 23 is 26 total minutes, so divided by 2 gets us 13 minutes. So if we add 13 minutes to 5:23, we get 05:36. Then if we take the difference between 6:12 and 5:49, that would be 72 minus 49. 23 total minutes divided by 2 is 11.5. So if we added that to 49, we'd get 6 o'clock. Okay, and there we go. There's our answer. Start time is going to occur from 5:36 to 0600, meaning this DR of 5:40 is pretty reasonable. And that we could then put in as our first answer for the problem. And then from there, see if morning stars occurred at 5:50, so that's pretty realistic to what we calculated. We were probably reasonably accurate. And then next we'll go on to actually running these morning stars.